So 10 minutes, you said?
Well, give or take. All right, so I gave you this worksheet. We are rationalizing denominators. So just like yesterday, with square roots, remember you're not allowed to leave a square root in a denominator? Same thing with cube roots, fourth roots, all of them. I'm not allowed to leave them in the denominator either. So before we begin, let's just try one with a square root and see if we even remember how we handle it. So if you look at number 1, bless you.
Thank you.
What are you supposed to do with something like number 1? Get rid of that square root in the denominator. Yeah, I multiply by √3 over √3. Because what happens is that numerator becomes 7 square root of 24. Bless you. And the denominator just becomes what? 3.
I don't mean to be.
Okay, question. Can I reduce this 3 with this 24?
Yes.
No. They either both have to be in a root or both be out of a root. I can't ever cancel something that's in with something that's out.
Oh, I thought you said he simplified the root 24.
That I can do,
That's
and
what
I
I'm
should
saying.
do. So the square root of 24, I'll just go over here real quick to simplify that. That would split into square root of 4, square root of 6. So I really have 2 √6 for that thing. So this is now 7 times 2 √6 over 3, which is just 14 √6 over 3. Okay, that's old news. We have done that. Just refreshing your memory kind of how that works. It works the exact same way with, well, I shouldn't say that. The goal is the same when I have cube roots or fourth roots or fifth roots. So I actually want to jump all the way down to number 9. Because 1 through 8 is just square root stuff that we've already done. So looking at number 9. Now, normally, I would, if that was a square root, I would just multiply by square root of 6 over square root of 6. But it's not a square root, it's a cube root. How do you undo a cube root? Kind of. So let's go back. If I want to undo a square root, I square it, right? Squaring a square root cancels it out. So using that same logic, if I have a cube root to undo it, I should cube it, shouldn't I? Oh, so what I'm really going to do here is I'm going to multiply by the cube root of 6 over the cube root of 6, but then I have to do it again. Yes. Because look at the denominator. Isn't this the cube root of 6 cubed? Right? So wouldn't that denominator just come out to be a 6? Think about it. What is 6 times 6 times 6?
36.
Oh, it's a, oh.
It's 216. If you look on that chart, the cube root of 216 is just 6. Isn't that something? So in my numerator, I'm going to have 2 times the cube root of 36. And I don't know, are there any perfect cubes that go into 36? Where's my list? No, because it's just 8. What I can do is I can reduce this 2 and 6 since they're both not under a root. So let's reduce those to become 1 and 3. So my final answer is just going to be cube root of 36 over 3.
Oh, so like if it was like I don't know the word for it. Like if it was a cube root, it had like a 4, which you have to multiply it.
You betcha, like 11. Let's look at 11. This is a 4th root. So to undo a 4th root, I need to do it to the 4th power. So I'd have to do all of, now, there is a shortcut, so you don't have to, it's not really a shortcut. You don't have to write them all out, but I'm going to right now, just so you can see them all. Right, I need 4 of them to undo it. So now that entire denominator just becomes a 3 because I have a 4th root, but it's to the 4th power. So that's just a 3, and then that numerator is just 2 times the 4th root of 3 times 3 times 3 is just 27. And then I can just look quickly and see if there's any 4th roots that go into 27. There's not, so that's my final answer. Does that make sense?
Whoa.
Wait, so now you can. Correct. So basically, in the first equation, number 1, couldn't simplify 3 of the 4. I mean, you can't simplify them anyway. But then in number 9, you simplified the 2 and the 2 and the 6, but then could say like 11 had like better numbers. Could you simplify that?
So if they're
Like, why
both,
were you able to simplify it in number 9, but like you can't simplify it for others?
because they have to be, the two numbers both have to be either out of the root or they both have to be in the same root. So 2 and 6 are both out of the root, and I can reduce 2 and 6 with each other.
Yeah.
If these numbers right here, if that had been a 2 and a 4, I could reduce them because they're both not under a root.
Okay.
As long as they're both not under a root, you can reduce just like any other fraction.
Okay.
If they're both, if I had a, let's just pretend I had a 4th root of 3 down here, I could reduce the 27 and the 3 in the root. But if I have one that's in a root, like 27, and out of the root, you can't touch them with each other. They either both have to be in or both have to be out. Does that make sense? Okay, why don't you guys try 10 real quick?
Oh, wait. Oh. Oh. Oh, wait, we're in the wrong spot, so we're just gonna look at our own.
So it's a cube root. So you know you want 3 of them all together. There's already one there. So you just need 2 more of them. Okay, what's my denominator? Just a 3, nice and easy. That numerator is going to be what? 6 cube root of 9. Is there anything here that can be simplified? Yeah, 6 and 3, they're both out of the root. So let's reduce them with each other. So I'd end up with just 2 cube root of 9. And you're done. There is no perfect cube that divides into 9. So fully simplified answer, and I'm done. See, I told you it wasn't that bad. And what's even on the back? So on the back, it's the same idea. Let's just do one of these variable ones. So what's nice about these, see how it says right in the directions that we're just assuming that everything is positive. So we don't have to worry about absolute values here. We're just like, hey, don't worry, everybody's positive. But I do the exact same thing. So on 19, for example, if I want to undo that, I have to do cube root of v squared, cube root of v squared, and then one more time. So if you, I always just start with the denominator. I have a cube root and I've cubed it. So those things cancel out. So the denominator right here is just going to be what? V squared, that's it. Cubing a cube root gets rid of the whole house. It makes it go away. And then in the numerator, I just multiply everything together. So I'd have 3v, and then what do you think is in that root? It'd be the cube root of what?
V to the 4th.
Yes. And now you would simplify that. Right, bless you. So first thing I might do, well,
You take out
Wait, can that be simplified?
yeah, so I have v over v squared, so I can reduce those two with each other. So v over v squared, wouldn't that leave me with just a v in the denominator? So 3 cube root of v to the 4th over v, because I'm canceling those two with each other. I can simplify this too, right? I have to split it up though, so I'm going to do some work over on the side. So that becomes cube root of v to the 3rd times cube root of v to the 1st. So I get V times cube root of V. Oh, I'm sorry, I
Not
didn't
like the
realize I
letter
was off.
V, it looks like a, I don't know.
Oh, yeah, next, like, it's the.
There we go.
That's confusing.
Yeah, so now I have 3. This thing just simplified to be this. V cube root of V all over V, and I can cancel these V's out because they're both not in the house. So my final answer is just 3 cube root of V. If you guys would be so kind as to just do, oh gosh. How about multiples of 4? That's it. And what do we have until 26? I think it's 26. I mean, just multiples of 4.
Multiples of 4. Do you want
Just to try. And whatever, you know, if the bell rings, then just turn in whatever you have. Because I did make that deal with you.